Good morning. Okay, so this morning our learning target is I will use equivalent proportions to problem solve. What does that even mean? Okay, I want you to turn and talk to your table group, okay, and I want you to come up with your understanding of what the learning target means. So put it in your own words. Do you guys know what a proportion is?
To solve a problem.
Not sure.
Well, I mean, it's just like, it's pretty simple.
What do you mean?
Like, that's what it means.
What does what mean?
I will use equivalent proportions to solve.
What's an equivalent proportion?
Proportions that are the same, like parts of something.
Parts of something that are the same. Okay, good. I like that. What did you guys come up with?
I would need equivalent properties to problem solve.
Okay. So what does that mean? Like equivalent properties?
I need the same properties to solve the problem.
Have you ever defined a word with a word before?
Nope.
Have you ever had anyone else define a word with the word before? Like if...
Yeah, I have.
Yeah? Does it help? Is it helpful?
No,
Not really. Okay, so you need to find a way to explain it where you're not necessarily using the words in the learning target. Okay? Okay, you can do it. Okay, what did you guys come up with?
Ratio. Ratio is like one thing over another thing, and the likeliness of it happening or something like that.
I like how you're talking about like probability, likelihood. Okay, but what does that have to do with like equivalent proportion?
I have no idea.
Okay. Well, think about that. What does equivalent mean?
Equal to.
Okay, good. Okay. What does it mean when something's proportionate?
It like is it a constant rate? Constant rate of proportionality. Like
Okay.
the
Can
rate
you
of
give an
quality.
example?
Like a graph that continues.
Slope of 2.
Yes.
Okay. So what do you mean by that?
It increases or decreases by 2.
By 2 each time. Okay. Like that.
So we can tell that in
Okay. So
30, their best and most ratio.
our learning target. I will use equivalent proportions to problem solve. What does that mean? What does it mean to be an equivalent proportion? Yes, Dylan. Parts that are the same. Good. Equivalent definitely means same. So by parts, what do you mean? Parts of?
Speech? Parts of, I don't know.
Okay. So Jack just mentioned parts of speech, right? If you had equivalent parts of speech, right, you could use words that are what? Yeah.
I was gonna say linear parts. But you use speech or
Parts of speech, like verb, noun, adverb, pronoun. Yeah. So could you think of, like within your group, I want everybody to think of 2 action words that mean the same thing. Turn and talk to your neighbor. 2 action words that mean the same thing. You're like, English? This is geometry. What do you guys think? 2 action words that mean the same thing. What do you think? What's that? Fight and attack. Okay, that's a really good example, Micah. Can I use your example?
Sure.
Awesome. Okay. I need you back in 5, 4, 3, 2. Hey, I know I have your attention when you're not talking and you're looking at me. Okay, good. Micah gave me permission to use his example of like fight and attack. Okay? So those are 2 action words that are similar, right? One may be more aggressive than the other, okay? So that's an example in English. In geometry, we're dealing with shapes. So when Dylan said same parts, okay, in chapter 4, we were dealing with proving that triangles were congruent, right? How did we know when triangles were congruent using side, side, side? When all of the sides were congruent. Okay, but in a triangle, were all the sides equal within a triangle? Not always, right? I mean, they could be equilateral. Okay, but if you had 2 triangles, you knew they were congruent when what? When their corresponding sides were congruent. Good. So we're talking about corresponding parts being not equal, but similar. Okay, that's what our learning target is talking about, right? We're going to use equivalent proportions. So we're talking about corresponding parts of shapes. Okay, but unlike when we were proving that something was congruent, now we're just going to be looking at things that are similar. Okay, how many of you ever heard the term like these things are proportional? Okay, raise your hand if you've heard that before. Raise your hand if you've heard it before. Okay, so some of you. Some of you have heard the word proportional before. Now, it's not one of our vocabulary words that we're going to cover today, but it is something we're going to talk about, right, within the context of today's lesson. All right, so your entry task. The table at the right gives the wins and losses of a baseball team. In which years did the team have the best record? And explain, right? The explain part's the really important part. How many of you found what you believe is the team with the best record? Okay, keep your hands up if you've explained how you know it's the best record. Okay, so I'm going to go about half the group. So I want you to make sure that everybody in your group, okay, understands both how you chose the team with the best record, okay, and why. The why is important. So, what did you do, Dominic? How did you find the percentage? Okay. So you divided the number of wins by the total number of games to find the percentage. Is that how you found your answer?
I did it by wins by losses.
Okay. So did you have the same answer?
Yeah.
You had the same answer?
Well, it's just different numbers, but it's still the same answer though.
Okay. So do you think if you ranked all the teams that your ranking would be the same? Using your different... Could you try it? Like if you're going to rank like the best team to the worst team. Okay? I want you to use your method, and Dominic, I want you to use yours, and then I want you to compare. Okay? How are you guys doing?
Good.
Did you guys all agree on which team had the best record?
1970 and 2010 are the same. Like they have the same.
I'm sorry? You mean the year 1930 and the year 1970? Are they exactly the same, or is it just the same number of wins?
1930.
1970 and 2010?
Yeah, like when you add the two together.
Okay, it's the same number of games?
Yeah.
Okay, but is it the same number of wins?
Oh, no.
Okay. Something to think about. All right, what'd you come up with?
Well, we talked about
1890 and 1930.
Okay.
And
Did
they
you...
had a 250% win rating, win to loss ratio.
So did you divide the number of wins by the number of losses?
Yeah.
Is that how you guys did it?
And he did the number of total,
I did the number of wins divided by the total games.
Total games. So you added them together to figure out the total number of games. Did you get the same answer when you were using the two different ratios? Yeah? Okay, good to know. All right. Here we go. All right, so with any question, Sean, it's important to think about, like, what is the question really asking you to do? So this says, in which years did the team have the best record? So your answer to that question, okay, may vary depending on what you feel like the best record means. So what do you guys think they mean by best record?
Win to loss ratio.
Okay, win to loss ratio. So win to loss ratio. How did you determine the win to loss ratio?
Well, I'm not really sure if this is like 100% accurate. But you see, what I did is I just took 60 and divided it by 24.
Okay, so you divided the number of wins by the number of losses?
Yeah.
Okay. Who else did that? Divide the number of wins by the number of losses. I talked to a lot of groups that were doing the same thing. Did anyone else figure out their answer in a different way? Okay. Anthony, what did you do?
I added up the
Jack, can you put that down, please?
and then took the wins and divided it by the total amount of games to get the percentage of the amount of times that they won.
Okay. So Jack took the number of wins and divided it by the number of losses. Okay, Okay, and Anthony had the number of wins and divided it by the total number of games. Okay, did anyone else have a different method for finding the best record? Yes. Nathan.
You need to divide by 2.
I'm sorry, could you repeat that?
I took both the numbers and then divided by 2 or a common factor, so I did 6. So I get like that.
Can you run me through that one more time?
So I took both the numbers,
Okay. Which numbers?
wins and losses,
Okay.
and I divided it by 2,
Okay.
and like I kept dividing it down to 2, and 5 and 2 was like the lowest.
Okay. So were you creating a similar situation to Jack where you had wins over losses, or did you do something similar to Anthony where you had wins over total games? So what numbers you divided? 60 and 24?
Yeah.
Okay. And you just kept dividing by 2. When you got down to where you couldn't divide by 2 anymore, what did you have left?
5 and 2.
5 over 2? Or 5 to 2? Okay. What did you get for the other 4?
I mean, not by 2 of a common factor of each other.
Okay. No, I understand. And then, so you kept dividing and you got 5 for 60, and you got 2 for 24. And you divided the same number of times?
Yeah.
Okay. And what did you get when you did the same thing for 1930?
I got 5 and 2 as well.
What's that?
Got 5 and 2 as well.
5 and 2 as well? Okay. So you're not dividing the same number of times each time?
Not each
Did you
time.
keep track?
No.
Okay. I have to say that I think what you're doing is really interesting, and we're going to get back to exactly what you were trying to do a little bit later in today's lesson. So it's really good. Okay? All right. So record could be wins to losses or wins to total. And I'm not going to answer which team had the best record, okay? But I think the group in the back did both, and they found out that both teams had the best record. But what's really important is what you guys were discussing here, which is one of our words that we're going to make a prediction on the definition, which is ratio. So we have 3 words that we're going to focus on today. The 3 words are ratio, mean, and extreme. So say ratio. Ratio. Everybody, ratio? Ratio. One more time, like you mean it. Ratio. Ratio. There you go. Okay, and mean? Mean. Mean. Okay, one more time. Say mean. Mean. And our 3rd word is extreme. 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 Like you mean it. Okay, extreme. Oh, come on. You guys can do better than that. Extreme. Okay, good. So what I'm going to do is I'm going to give each group a card that has each of the words on it. So you have one that says ratio, you have one that says mean, and you have one that says extreme. Now, within your group, I want you to come up with a prediction or predictions about what you think the word means, and you're going to write it on the back. Okay? So each table within your group is going to be responsible for at least one word, recording it. Okay, but I want everybody in your group to contribute to the collaboration of your prediction on the meaning. Okay? So you have 3 words. You're making predictions about their meaning.
Mean.
Yeah. Mean. Okay, stay with your group. Okay. Yes, on the back. I want you to write your prediction on the back.
Really?
Everyone knows it.
I know, but I don't know.
So did you guys make your predictions already? Okay.
Huh?
Which one are you going to do first? Mean. Okay, now you're going to record. Awesome.
Is it like mean, median, and mode?
That's what I want you to tell me. So that would be a good thing to write down, right? Like if you think it's mean from mean, median, and mode, like write that, give it the context, okay, and then give the definition. Okay, so your partner's helping you out over here. Which word are you guys working on?
Ratio.
Ratio. And what's your definition?
Comparison of two percentages.
Okay. Do you have any other, does everybody agree on that prediction, or? Yeah. Okay. Good. Did you already complete your other two? What'd you have for extreme?
Isn't it like the highest value and the lowest value? Because it's like the extreme of the set of numbers.
Okay, well, we're going to figure that out. Okay. So you're thinking like either end? Okay. High and low? Do you guys make your three predictions? Okay, can I have your cards? We're done. Okay, so we're not quite finished?
No, we're not.
Okay, so I want to collect your three cards when you're done. How are we doing?
I don't know.
You're not sure?
Not too hot.
Okay, so where are we at? Which word are we working
I
on?
feel like I remember this. I'm pretty sure I do. I remember
Okay.
this. It's something about like a really high number.
Okay, so put that down. That sounds like a really good prediction to me. Have you guys heard the word extreme before used in a mathematical context? What were you saying?
I feel like Nathan's right because that's what I was thinking about.
Okay.
Wait, that's like a high number.
Okay. So while Nathan's recording that, what's the next word we're going to work on?
We were thinking of ratio. I was thinking like a proportionate, like constant rate.
Yeah.
Okay. So constant rate. So what's a rate?
It's like I remember it was like a rate of something.
Rate is in now.
Are you guys thinking of like slope? Like rate of
Yeah.
change? Okay. Write that down. Okay, do you have your three? Can I have this?
Can I
Thank you.
different pencil?
Nope, I'll take it. I'll loan you a pencil. I'll give it back at the end of class. Yes.
You said that this is not the one that we went.
Might be related. See? Okay, so finish up your predictions. I'm going to come around and collect them. Oh, you have pencil? You're good? Okay.
I said I could use a different one.
Okay. You can have it back at the end of class. Okay, I'm going to come around and collect your cards. Micah, save the group. Okay. Have your prediction. Thank you, Justice. Thank you, Cameron. We got all three?
No.
No idea for ratio? We couldn't come up with one?
No, Carissa doesn't know.
What?
Okay, I'll take what you got.
I had me.
All right. One more group. Here we go. Okay, let's see what we came up with. Okay? So I'm going to take your predictions and then fifth period's predictions, and we will compile them. But I'd like to read back some of the predictions that you have now for ratio, mean, and extreme. So some of your predictions for ratio. Percentage between two things. Someone gave an example. For every 1 pound, you have 3 apples. So it sounds like somebody does a lot of baking. Comparison of two percentages. The difference between two amounts. And the relationship between given numbers and data. Okay? So it sounds like most of you agree that it definitely has to do with two different things. Okay, and then your predictions for mean. We have lots of people who stated average. When you add all the numbers and then divide to get the average. Okay? And for extreme, the highest and lowest number, highest point. The mean of all the ratios. High number, highest and lowest point from given data. Okay, so we are going to finalize a definition for these 3 words. in our next lesson, but you're going to find that we use these 3 words in context a lot today. Okay? So it's going to be really important that you're looking for those words, and I'd actually like you to like underline or highlight them in your notes as you see them, because we will refer back to them in our next lesson. Okay. Anybody stand up for me? Stand up. Stand up. Okay, turn and face your partner. Turn and face your partner. Okay. I'll wait for you. Okay, using any portion of your hands or arms, I would like you and your partner to create 2 proportional shapes. 2 proportional shapes. Okay? So what shape do you want to do? You want to do a rectangle?
Sure.
Or, okay. So I'm going to make mine bigger.
Okay.
Okay, and then okay, proportional. That means they don't necessarily have to be congruent. Okay, I'm looking for proportional. I want to get an idea of where you're at with proportional. Okay, change shapes for me. Use your arms this time, not just your hands. Use your arms. Okay, you want to do a circle? So can we do the one this way?
Oh, yeah.
Like, make it really big?
Yeah.
Really big. Okay. All right, have a seat. Okay. So our first problem today is actually dealing with writing a ratio. Okay? Bonsai trees. The bonsai bald cypress tree is a small version of the full-size tree. A Florida bald cypress tree called the Senator stands 118 feet tall. What is the ratio of the height of the bonsai to the height of the Senator? Those are 2 trees, not like a Congress senator. Right? We're talking about 2 trees here. And we have to create a ratio of the height of the bonsai, okay, to the height of the Senator. So over here, I don't know if you can read this very well, but this says 15 inches. Okay, so this is a little diagram of our bonsai tree. Okay, and then we're also given the height of the Senator. How tall is the height of the Senator? 118 feet. Okay? If we're going to create a ratio of the height of the bonsai to the height of the Senator, what should we try? Yes, Brandon.
Converting the 118 feet into inches.
Okay.
Changing the 15 into feet.
Good. I'm glad that you guys have some experience with ratios, and you absolutely do want them to be in the same units. So we do need to convert. Okay, so let's convert the 118 feet into inches. How do we do that? We multiply it by 12 because there are 12 inches in a foot. Okay, so this is 118 feet. Okay, I know you've been doing conversions in your science class. Okay, so we'd multiply that by 12 inches over 1 foot. Okay, there's 12 inches per foot. Okay, and we multiply 118 by 12. What do we get? 1,416. Okay, and that will be inches. Okay, so how many of you are planning to take chemistry at some point in high school? Taking chemistry at some point in high school. Okay, awesome. So I'd like to show you something that is pretty simple when you're converting just from one unit to another. Okay, but in chemistry, you're going to have to convert through multiple units. Okay, so when you're doing a conversion, it's really important to set it up this way. Okay, you put your starting value in its units, and then you're going to multiply it, okay, by exactly what you all said, 12 inches, because there's 12 inches in 1 foot. But then as you go through and you do you're multiplying, right? We multiply across the top to get 1,416 inches. But we also can do a little bit of multiplying like across the bottom, and we can cross-cancel our units, right? So these units cancel out, and that's how we're left with inches. Okay, so again, it's not really that necessary. Most of you just do that in your head when you're converting from one unit to another, but when you have to convert through multiple units, okay, remembering to cancel out your units is going to be really helpful. Okay, so now we know that a senator is 1,416 inches tall. Okay, so what would our ratio of the height of the bonsai to the height of the senator be? What would it be, Hannah?
15 inches to 1,416 inches.
Good. The height of the bonsai to the height of the senator, okay, is 15 to 1,416. Okay, so this is a ratio, but it's not written appropriately because we always want to make sure we do what? Yes.
Bring it down to like research, like it's simplified.
Yes, and Nathan, this is exactly what you were doing before, okay, with those baseball scores. You were essentially simplifying, okay, but it's best to leave it in a fraction when you do that. So what are the factors of 15? 3 and 5. Good, 3 and 5. Okay, and how many times does 3, okay, go into 1,416? Josh. Okay. Okay, and then because a fraction is basically a division problem, what happens with the factors of 3 over 3? They cancel, they become 1. Okay, and we're left with our simplified ratio, which is 5 to 472.
Pretty confusing.
Okay, so if it's confusing, that means you have a question. I'd love to hear your questions, Jack.
I don't have any.
Okay. Can anybody tell me why I crossed out the units in the ratio? Yes.
They cancel each other out.
They do cancel each other out, but why don't I need units in a ratio?
Because it doesn't matter. It don't matter.
You're right, it doesn't matter, but do you know why?
It's not worth it.
Yeah, can you say that again?
They should be proportionate. They should be the same.
They should be proportionate. Okay, so guys, I want you to think about maybe a ratio that you're a little more familiar with, right? Let's talk about, like, boys and girls in the school. Okay, so let's say, I don't know that this is accurate, okay, I'm making this up, but let's say that in Glacier View, for every one girl, there are 2 boys. Okay? So that would mean that that ratio is probably pretty consistent, right, throughout the school. So if we looked at 7th grade, okay, one girl to 2 boys? 1 girl to 2 boys. Okay, that's a smaller group of people than if we looked at the entire population of the school, but it would still apply. Okay, so ratios are important because they don't require units. You can scale them up or scale them down. You can use inches, you can use feet, you can use miles, as long as you are talking about using the same units for each. Right? So for every 5 inches, for the height of the bonsai, the senator is 472 inches. But we could do the same thing with feet. For every 5 feet, it would be how many feet for the senator? 472. We could do it in miles, right? For every 5 miles, it would be 472 miles. Okay, so you can use any units you want. That's why it's important to cancel the units. Okay, now I want everybody in your groups, okay, to try the next problem. This one doesn't come with a diagram, but feel free to draw one if that's helpful to you. Okay? So same thing, we're talking about a bonsai tree. Okay? This time it's a bonsai tree is 18 inches wide and stands 2 feet tall. So now they're talking about creating a ratio of height, okay, of width to height.
it like 12?
I'm glad that you're converting, Chase. That's what a lot of people forget with this one. So what are you trying?
So, first off, I turn the height into feet.
Good.
And now I'm finding the factors of 18.
Mm-hmm.
But now I need a calculator. It's going to be a decimal.
You're on the right track. So everybody remembering to convert from feet to inches? Okay, looks nice. So is this feet to inches or inches? I mean, is this height
Inches.
to width or width to height?
That's with the height.
Is it width to height? Okay. Okay, so when we convert our feet to inches, how many inches are in 2 feet? Jack?
24.
24. So from writing my unsimplified ratio, what would that be?
Do you have to do it to inches?
What's that?
Do you have to convert it to inches? Or
You don't. You could convert the inches to feet, but in a ratio, you generally want to work with whole numbers. Okay? So in this case, it's best to go from feet to inches. That was a really good question.
Well, I got 0.75 feet to 1 foot.
Okay? Let's convert to inches. Brandon, what'd you get? Yes. Okay, and what was your unsimplified ratio? Okay. If we were going a ratio of height to width, that would be correct. Yeah, we're going width to height. Good. Okay, and then when we simplify this, what's a common factor for 18 and 24? 6. Okay, so we have 6 times 3 over 6 times 4. Okay, our 6's cancel. And we're left with our simplified ratio, which is?
3/4.
Good. And here's just something to recognize when you're reading a ratio. You want to read it 3/4. Okay? You can also write it with a colon. So when you read this, it's 3/4. That's how you would read it. Okay, questions on that? Okay? Let's talk about our next problem. So dividing a quantity into a given ratio. So now we're going to apply what we've learned about ratios to help us solve a problem. Members of a school band are buying pots of tulips and pots of daffodils to sell at their fundraiser. The plan to buy 120 pots of flowers. The ratio, number of tulip pots to number of daffodil pots, will be 2 to 3. How many pots of each type of the flower should they buy? Okay? So I would like you to work with your table group, okay, and come up with a strategy for figuring out if they plan to buy 120 pots of flowers and they want a ratio of 2 to 3, how many pots of each should they buy? Okay, so I don't just want an answer. I want a strategy. You need to be able to explain to someone else what you did to get your answer.
So, what you do is put 3.
Did you not have calculators? Okay.
Like, I know what the answer is, but I don't know.
There you go. Jack, turn around. Let's talk to the group. Okay. Face front. So you guys each trying your own strategy, and then you're going to share, or do you have an idea of how you're going to?
I'm trying to ask a question.
Okay. So what's your question?
You didn't say anything. You haven't said a single word.
Jack. Okay.
I'm kind of scared of the camera.
Okay. Okay. So what's your question?
Just like, what do we do?
That's a really good question.
That's what we're trying to figure out, Jack.
Well, you guys aren't really
We know we want a ratio of 2 to 3.
Look, we have 1, 2, 3, 4, 5 minus 2.
So, Jack, let's simplify it. Let's talk about like the 1 girl to 2 boy ratio I was talking about earlier.
Yes.
If there were 6 students in this classroom and I told you there was a ratio of 1 girl to 2 boys, how many girls would there be?
There'd be 2 girls.
And
3 boys.
you mean 4 boys for a total of
Yeah.
6? Okay, how'd you do that?
Just simple math.
Okay, so describe your simple math to me. What addition, subtraction, multiplication, or division did you do in your head?
Division.
You divided what by what?
I divided the ratio, which is 1 over 2.
Okay,
Half divided by 6.
okay, and you got?
2 over 4.
Okay, but 6 divided by 2 is 3, so how did you get 2 to 4?
Multiplication.
Okay, so what did you multiply?
2, 1/2 times 6.
1/2 times 6 is 3.
We have to get
Well, I don't know.
whatever 2/3. We have to.
So you said that there were 2 girls and 4 boys for a total of how many students? 6. So how do you take 2 and 4 and get a total of 6?
So you take, so what you gotta do?
Did I add, subtract, multiply, or divide
Divide.
to get from 2 girls and 4 boys to a total of 6 students?
You added.
You added, good. Okay.
What it would be.
So let's take that same ratio, right, 1 to 2, and let's extend it to a larger population. Let's say there were 24 students in the class. How many would be girls and how many would be boys?
So you have to take the total and then
Well,
divide it.
what you gotta do is you get 6. Wait, 1 to 2 you said?
Mhm.
See, on a larger scale, it actually makes it quick more difficult.
Yes, which is why you have to be able to explain how you got your answer so that you know what to do next time. So, I know it's not easy, but I want you guys to think about it. Okay? So what did you guys come up with? Not done yet. Okay. Okay, how are we doing? What are we trying?
We're thinking because you add them up and equals 5, so maybe 120 divided by 5, and then, no, I don't know.
I think you're on.
I tried 24.
Okay.
And then tried finding 2/3 of 24, which is 60.
You guys have half of it. You're almost there. I promise you, you're almost
So
there.
I wasn't confusing myself.
No. So you took the 120 and you broke it into 5 parts, right? How many of each of those parts should be tulips, and how many of each of those parts should be daffodils?
48 to.
Okay, now explain that to your group.
Well, if it's simplified, then it's 8 to 12, and then it's simplified.
What are you guys trying?
Yeah.
You have,
We don't have to simplify.
well, it has to total 120. So you guys multiplying?
Well, so at first we divided by 3 and we said it was 40 over.
48 over
Okay. We have a whole of 120 pots, right? And we're breaking it into pieces. And we want 2 of those
Would you
parts,
divide it by 5?
right, to be, what's that?
Would you still divide it by
Why
3
would you
or
divide
5?
by 5?
Because that's how many parts there are to it.
Really? That's amazing. That's brilliant. Explain that to your group.
The catch. See, this is half. So what you do, 18, and what's half, and then plus 6.
Okay. Thank you. You guys, this is awesome. I'm going to pull you back. I need your attention in 5, 4, 3, 2. Thank you for trying this. Without me telling you what to do, you just tried it. And through your conversations, some of you figured out what needed to happen. So I would like you to share with the group, if you feel like you have a really good idea of how to start this problem, what you should do. Okay, Brandon, start us off. Okay. So hold up. Pause right there. Okay? So I know I have your attention when you're not talking and you're looking at me. Okay, but Brandon has the floor, so I need everybody to turn and face Brandon while he shares his answer. So you're turning your whole body. Turn your body. Jack. Okay, let's turn. Allie. Okay, thank you for turning and facing Brandon. Okay, Brandon, will you explain why you added the 2 and the 3 that are in our ratio?
Because it would equal all the flower pots, because you have to just add the ratio to equal all, and then you divide the 2 and 3 equals 5 by the 120, because then it splits the 120 into 5 parts,
Okay.
and then that equals 24, because then you can just do the 24 times 3 and the 2, because then it splits it back up into the ratio, and then whatever you get from that, which was 48 and 72.
True statement.
Okay, now everybody turn and face the board. Okay. Now, Brandon's group wasn't the only one to come up with 2 to 3 being 5 parts of the whole. Okay. Dylan, I think you were talking about that too, right? 2 to 3. That's 5 parts of the whole, and we have 120 pots. That's the whole, right, number of pots for this particular for the school band, right? So they're going to sell these, and they know that, okay, daffodils are slightly more popular than tulips, right? So they're going with a 2 to 3 ratio. But that means that, just as Brandon said, we're breaking that 120 up into 5 parts. Okay, and we have to figure out, if we broke it up into 5 equal parts, how many would be in each part. Okay, and the answer is 24. Now, you can also do this algebraically, right? I mean, this is high school geometry. You guys have gone through algebra. We can take this ratio and make it into an equation, right? So we don't know what x is yet, right? It's the number of each type of pot, okay? So there are 2 times the number of each type of pot plus 3 times the number of each type of pot equals 120 pots, which gives us 5, right, of the number of each type of pot equals 120. You divide by 5 and you get 24. Okay, and so then we just apply x equals 24 back to our ratio. So what's 2 times 24? It's 48. So we're going to have 48 tulip pots. Okay, and then 3 times 24 is, so we have 72 daffodil pots. It's a very timely problem. I just had my first daffodil bloom in my yard today. I know, gorgeous.
Very nice.
All right, let's do one more. Now that you know how to approach this problem, try another one. Okay, here we go. This time we're dealing with one of the geometric, properties that we've learned about this year, supplementary angles. I think it's helpful to draw a diagram for this one, so that's your hint. Okay, we have the measure of 2 supplementary angles are in the ratio of 1 to 4. What are the measures of the angles? So try drawing a diagram.
Supplementary angles are equal to 180 degrees. Oh, we don't know.
No, you're fine. Good. So I would draw a diagram maybe of supplementary angles, right? 2 adjacent supplementary angles. And label them with what you know about the ratio. Sean, are you figuring this out in your head?
Yeah, it would be 180 divided by 4.
Is it 180 divided by 4?
And then,
How many parts are in the ratio? So remember, a ratio differs from a fraction slightly, right? So in a fraction, the numerator is the number, right? And the bottom is the parts. But in a ratio, like each part of the ratio contributes to the whole. How did you get 36? Okay, which was, in this case, what did you do?
1x plus 4x is ratio 180.
Good.
Then it's 5x equals 180.
Okay.
And divided equals
So you divided by 5 instead of 4.
Yes.
Do you see how she got that, Sean? Okay. So is 36 is which angle?
angle 1. The small one.
It's the small one.
Wait, so the supplementary angles are 90 degrees, right?
That's complementary.
Wait, so why does it say 2? Wouldn't that be 360?
No, it's not. It's saying that there are two angles that make up like a linear pair. Two adjacent angles are supplementary, so that means they equal 180 degrees. Okay. Okay. Did you get it? Nice. Good work. Okay. Make sure that everybody in your group understands the answer. Okay? See if we remember our numbers. Okay. Number 19. That's okay, I got you. Olivia.
Of course it's me.
What equation did you write for this problem?
So 4x plus x equals 180.
Okay, are there any questions about the equation that Olivia wrote? About where she got this information? Okay, and so then x would equal 36. Okay, but the question is, what are the measures of the angles? Okay, so if you drew a diagram, right, you have a small angle. Okay, I'll call it angle A, and a larger angle that's angle B. So what would the measure of angle A be? 36 degrees. Okay, and then what's the measure of the larger angle? Dominic? 144 degrees. Nice job. Okay, any questions about that? Okay, so I know this is a long period. Okay, so I'd like to give you a break. Okay, so you can have a 5-minute break. Okay, so we're going to now look at extended ratios. So an extended ratio compares 3 or more numbers. Okay, in an extended ratio, A to B to C, the ratio of the first two numbers is A to B, and the ratio of the last two numbers is B to C. And the ratio of the first and last numbers is A to C. So if you were just taking that extended ratio and comparing just two, okay, it would be A to B, B to C, or A to C. Okay? Questions on that? All right, so this is really similar to the second example that we looked at. Okay, only we're going to be dealing with more than two quantities. So the lengths of the sides of a triangle are in the extended ratio 3 to 5 to 6. The perimeter of the triangle is 98 inches. What is the length of the longest side? Okay? As a matter of fact, this problem is so similar to problem number 2. I'm going to have you work with your table groups and determine what the length of the longest side is.
So, we're going to do for number 3.
I added 3 plus 5 plus 6.
Good plan. So how are you going to take what you did in the last problem and use it to help you with this one? What's that?
Use the numbers.
Okay. Are you going to add, subtract, multiply, or divide? Okay, good. What are you going to add? Which one? So you're not going to add 3 then? Okay. Do you have any questions here? No? Just not a morning person. Aaron, how you doing? You with us? Okay. So what are you trying? What's that?
3x plus 5x.
Plus.
Would you
Okay. And what would you set all that equal to?
And then the hypotenuse is the longest leg.
Okay. Well, we're doing a perimeter. How do you find perimeter? Yeah, you add up all the sides. Okay. Do we know the total of the perimeter?
98 inches.
There you go. So what we set it equal to? There you go. Did you find it?
Yeah.
Nice job. Okay, Nathan, why don't you try?
So I did, or no, we did 3x plus 5x plus 6x.
Good.
And then we got 14x, and then 98 divided by 14 is 7. And
Good.
So 7 was x, and then we multiplied 7 by each of the numbers.
Okay, so the answer to the question, what is the length of the longest side? The answer would be
42
42.
inches.
Good. And you even know the units. Nice job. Why don't you guys go ahead and start on the next problem? Okay, if you have finished the first one, please start on the got it. Good. Don't forget to include units in your answer when it's asking for length. You should have a unit of length in your answer.
All right.
Nice job, Micah.
I got the answer. I outflunked it.
Okay, we're good. Brandon, I feel like we're going too slow for you. Would you like to start the practice?
Yes.
How are we doing?
We good.
So what did you get for the first one? 7 is, well, 7 is what x would be equal to. So then how would you determine the longest side? What's that?
The hypotenuse is the longest leg, so you take the biggest number out of the ratio, and then you multiply it by what x is.
Dylan, you're right that we are going to use the largest number in the ratio, but it's not necessarily hypotenuse because we don't know if this is a right triangle. It is. We are looking at the longest side though.
Oh, I don't know why I said hypotenuse.
Because you're used to using that term with longest side and right triangle. Jack, I'd like to remind you that you're supposed to be facing the front.
Okay.
Okay, can you put your legs underneath the table? And remember that our ideal was you sitting in the front so that cameras behind you and won't distract you unless you're turning around. Okay, I'd love to hear your explanations of your answers. So I'd like your attention in 5, 4, 3, 2. Thank you. Okay, Maya, I drew your number, so you are up. Will you explain to us how you set up this problem? So we should be facing Maya.
The first one?
Yep.
I set it up by I took 3 to 5 to 6, and
Okay.
you get 3x plus 5x plus 6x equals 98.
Okay.
And then I added them all together, I got 14x equals 98, and then I got x equals 7. And then I plugged 7 in to the x, and then I got 21 to 35 to 42, and then it would be 42 inches is the longest side.
Good. So if we took the largest part of our ratio and multiplied it by 7, we would get that 42 is our longest side. And what units should we use for that answer?
Inches.
Inches. Nice job. Okay, are there any questions for Maya about how she found this answer? Okay, so let's look at the got it problem. Okay. So, okay, Hunter's not here. He owes me an answer. Let's see.
He misses so much school.
Dominic. Okay, we explain how you set up got it number 3. Okay, so we're going to wait for everybody to turn and face you while you explain how to do this problem. So everybody should be turning and facing Dominic. Yep, we got it. Okay, so I'll read through the problem and you're just going to tell me how you're going to set it up. It's okay if you don't have the answer ready yet. Okay, so the lengths of the sides of a triangle are in the extended ratio 4 to 7 to 9. The perimeter is 60 centimeters. What are the lengths of the sides? So how would you set this up?
4x plus 7x plus 9x equals 60.
Nice job. Did anybody find the value of x in the second problem already? Chase, what'd you get?
3.
Okay, and that means the longest side would be equal to, yes, Jess.
No, that's not what we have to find out.
Okay. What is it asking for?
What are the side lengths?
Good. What are all three side lengths? Okay, so what's the smallest side length?
12.
12 what?
6 centimeters.
Good, 12 centimeters. And then
21.
21.
And then 27.
Good. Okay, any questions about that problem? Okay, so we're going to move on to proportion. So a little while ago I asked you to stand up and create similar shapes, right? So we're creating proportional shapes. Okay, an equation that states that two ratios are equal is called a proportion. So several of you said that you'd heard of a proportion before. An equation that states that two ratios are equal is called a proportion. The first and last numbers in the proportion are the extremes, and the middle two numbers are the means. So they're giving us an example here. Okay, so in the proportion 2 to 3 is equal to 4 to 6. Okay, 2 and 6 would be the extremes, and 3 and 4 would be the mean. Okay? So in a proportion, the product of the extreme equals the product of the means. That's called cross products. How many of your elementary teachers used the butterfly method? Anybody? Yes. Yes. Okay. So, although I appreciate, right, the very flowery language, right, and the comfort level that it gets you to use that, it's not the butterfly method, it's cross products. Okay? So, yes, but it's also called cross products. Products is which math operation? Multiplication. It's cross products because not only are these two ratios equal, but 2 times 6 is equal to 3 times 4. Okay? So it's called cross products because you multiply numbers that are across from one another. And yes, it does happen to look like a butterfly. Okay. Yeah, it's a method that was used to solve proportional relationships, but it's actually cross products. Okay, how many of you have heard of cross products before? Raise your hand if you've heard of cross products.
I've done it similarly, but I just drew lines instead of circling.
Okay.
I made it into a stick figure.
I actually just highlighted.
That works too. Okay, so we are not dealing with the very simple cross products that you've probably dealt with in the past because you've gone through a whole year of algebra. Okay, so of course we're going to throw some. Oh, you need me to go back up? Okay. Okay, we're going to throw some variables in here for you. Okay, because you can multiply when there's variables involved, and you can solve single variable equations. You should see lots of nodding. Yes, we can totally do that. Okay, so we're going to practice solving proportions. So what is the solution of each proportion? Okay, we're going to find the solution for proportion A and the solution for proportion B. Okay, you are sitting next to someone at your table group. I want one of you to find the answer for A and the other to find the answer to B. Once you are both done, hold on. I'm not done. I need your attention. I need your attention. Okay, once you are both done, I want you to turn and explain to your neighbor how you got your answer. Okay? So, Riley and Chase, when you're done, will you guys compare? Okay, thank you. Okay, go. One of you is doing A, the other's doing B. Rock, paper, scissors if you can't decide. Which one are you doing?
B.
You're doing B?
B.
Okay, my hint to you is to distribute. Okay, I use parentheses. Yeah, good. Okay, use cross products to help you. You got it? Okay, remember you have to be able to explain it.
Yeah.
Okay. What are you trying?
I'm not sure.
You're doing great.
Is this correct?
You're doing great. Well, what did you get? You guys are working on the same one, right?
Well, 0.8.
Well, there you go. Good job.
Oh, mine equals 5 equals 25.
Okay, if you are not sure about your answer and you want to double check, find someone else in your table group that's working on the same problem. See if you got the same answer. What'd you guys get? Okay. So now how do you solve for x? Yeah, you want to solve it other than, so you need to solve that single variable.
I don't know how to do B.
Okay. So what do you multiply for b?
9
You're gonna cross good 9 and y, and then 3 times
Oh,
y
y.
plus 4. Yeah, good. Yeah.
So for B, would you multiply
Yep.
that?
And distribute. Good.
Wait, what?
So you have to multiply 3 by
Oh,
y
so
plus
it's-
4.
Right.
Right.
Okay.
Good. What'd you get?
4.8. I didn't write it down, but
Okay, but you can explain it.
Yeah.
How you did it. Okay.
Yeah, I don't understand B. I understand A, but I don't understand B.
Why don't you understand B?
I
Decimals
don't
happen.
start.
Okay, well, start with cross products. So what would you multiply if you were using cross products? Did someone else at your table group do the same problem?
Dominance.
Okay, Dominic, how did you use cross products to help you with it? Okay, so if we were using cross products, what would we do?
Y times 9,
Cameron,
3 times y plus 4. So it'd be
can you come over here, please?
those two.
Yep.
So it'd be
Just like that.
9y
Okay, which problem did you work on?
equals.
A. Okay, can you go back and work on B for me?
My partner's doing B.
Okay.
Would you like me to do it?
Yeah, I would like you to do it also. Thank you.
Equals.
Good. You guys are on the right track. Okay, make sure you have shared your answer with your neighbors. She's not kidding.
24 divided by 4.8. Like that x equals 4.8. That means.
How are you doing? Did you distribute?
Me?
Because it should be 3 times 4 and 3 times y.
Oh, okay.
Okay. I'd like your attention in 5, 4, 3, 2. Okay. So I would like to apologize on behalf of all math teachers everywhere in causing you to believe that if you get a non-integer answer, that you've done something wrong. Okay? Decimals and fractions are going to happen far more frequently in the real world, okay, than integers will. How many of you have ever gone to the grocery store and been amazed, right, when your total comes to exactly like $5 or something like that? But yeah, because it doesn't happen very often. Okay, more often than not, right, you're going to get some tenths or hundredths of a dollar in addition to whatever the whole number answer is. Okay, I'll wait. Okay, so it's really important that you guys have some level of confidence with what you're doing, right? And not just the, forgive the pun, product of your answer. Okay? All right, so help me set it up. Okay, what would A look like if I'm just applying cross products? Okay? Hunter's still not here. Let's see. Okay, third time's the charm.
Number 13.
Nope, it's 18, which is Dylan. Okay, Dylan. Okay, so everybody's going to turn and face Dylan. Okay, explain to us how you set this up. Okay, not everybody's facing you yet. Hold on. Okay, I think we're ready. A. Okay, but she explained it, right? Okay, so help us set this one up.
Okay, so you multiply 6 by 4,
Good.
and then you put, divide by,
Okay, I'm going to give you guys a minute to talk about this problem. Okay, and we're going to move on to B. So Dylan, I'm going to come right back to you. So take a minute. Okay. All right, let's talk about B. Who can help us with B? Okay. Let's see.
Number 2.
Yes, it is number 2, Nathan. Great, you were ready to volunteer. I love it. Okay, let's set it up.
So it's 5.
Okay, hold on. Okay, who should we be facing right now? Nathan, because he's the one talking. So everybody turn and face Nathan. Okay? All right, Nathan, we're ready for you.
So it's y plus 4 times 3, 3y plus 12. And then you go 9 times y would be 9 is equal to 9y. And you get 3y plus 12. And then you subtract 3y from 9y. So it'd be 12 equals 6y. And then you divide 6 from both sides. You get y is equal to 2. And then you plug in 2 for y. And you get 2, 2, 3.
Okay, good. If we did plug it back in, we could see what each of the ratios was. But the goal here was to solve for the variable. Okay, are there any questions for Nathan on how he found y equals 2? Okay. Dylan, question?
I understand it.
You understand it. Are you ready to explain? Okay, awesome. So now we're going to look at A. Somebody turn and face Dylan.
Keep that 6 times 4 up there.
Okay.
Now, you divide 24 by 5, and then that equals x, which is 4.8, and then 4.8 times 5 equals 24.
Okay, so the only thing we're missing here is the other half of our proportion, right? So if we're setting up cross products 6 times 4 this way, what are the other two things we need to multiply to finish off our equation? 5 times x. Good. Yep. So now can you see how we got the 24 and why we divided both sides by 5?
Yeah.
Okay. And that's how we got x equals 4 8/10. Okay, questions for Dylan? Okay, good. You have 2 more. Okay, I want each person individually in your notebook. I want you to do both of these problems. 2 more. Yes.
So, on the homework, I'm confused about this. I'm confused about number 3.
Okay.
Like,
Because we haven't gotten there yet.
yeah, that's why.
Yeah.
And then,
Can you try the 2 that are on the board right now?
yeah.
Thank you. Okay, do you need a new pencil?
No.
Okay.
No,
Do you need something?
no, he is not cooperating.
Okay.
I'm doing A.
I know, I'm really.
What should you be working on?
Martha, you
You're
did
both
A
doing
for
A and B. You're both doing A and B.
Do your work.
Okay. Do you need a new seat, Micah?
No.
Are you sure?
Yeah, I'm fine.
Do you have a question?
Oh, ouch.
A little bit.
Okay.
I understand what you did with the last.
Okay.
So he took the number over here and multiplied it here, but it's just variables here, so do I do the same?
Yeah, same thing.
With
The only difference between multiplying this way and multiplying this way is that this one you'll need some parentheses because you have a math operation happening down here.
Okay.
Right? So you want to apply that 3 to both the M and.
Okay.
Does that make sense?
Yes.
Okay.
No, whatever you want. You can have that.
Are we missing a calculator here?
Nope.
Okay.
That's
How are we doing?
I'm lost. I'm lost.
You're lost.
I don't know if I did this right. So
Okay.
when I did across from this one, was
that's
I
good.
just supposed to make this 3m and this 3? So I did that part right?
Yes.
Okay, so then minus 3m.
It's fine. What you have there is good.
I divide this by 12.
Yep.
Is that okay if I simplify?
You should simplify, yes.
Yeah, so the end answer for B would be 5 equals m plus 1.
Divided by 12.
That's not simplified.
0.25.
So what I would recommend, Gabe, is that you try and get all of your m's on one side. So how would you move the 3m to the other side of that equation?
Oh, that's fine.
Yeah, there you go. It's the variables on both sides that's throwing you off. You got this. How'd you do?
It's 0.25.
Okay, so how did you get 4? Walk me through what you did.
15m equals 3m plus 3.
Good. Is that what you have, Chase?
Yes.
You have 15m equals 3m plus 3
Yeah, and you do minus 3m.
on both sides.
Yeah, so that's 12m is equal to 3.
Good.
Oh, wait, whoops. Wait, no.
Did you write out your steps, or did you try doing some of it in your head?
No, and then you have to divide by 12m, which is 0.25.
You divide by 12.
By 12, yeah, and it's 0.25.
Yeah, or 1/4.
Yeah.
Yeah. Good. What'd you get?
I don't understand how to do this.
Okay.
Because how do you do it with
So-
the n plus 1?
Well, you multiply, just like you would with the cross product of numbers. You're still multiplying. The only difference is after you're done multiplying, then you have to solve for the variable. You have a single variable equation, you have to solve for the variable. Okay? So how would you set up the first one? Okay, you need some variables. Oh, you're writing problems. Got you. I'll give you a minute. Oh, how are we doing?
We were like, because I was like, this doesn't seem right, because what Bella, or what a certain person did
I
was
divided it wrong.
they divided by 3, and she said that 4 is equal to m,
But you should divide by what?
divided by 3, so I got 4m.
No, you should divide by, you're dividing by whatever you multiply the variable by. So if the variable is being multiplied by 12, what should you divide by? Yes, you should be dividing by 12. Okay. All right, here we go. All right, I would like to go over B with you. So I'll know you're ready when you're not talking and you're looking at me. Okay, sit flat, please. Okay. All right, it's always a learning process for me, right? That there are times when I should review how to solve single variable equations when there are variables on both sides. So that's one of the reasons I want to go over B, because you end up with variables on both sides of your equation, and that's throwing some of you off a little. So you have the first step right. You know that you need to multiply your cross products. Okay, so when we multiply 3 times m plus 1, that should equal 15 times m. Okay, and everyone's paper that I looked at had that it attempted this problem. Okay, it was after this that we started having difficulties. So this is just an algebra review. Okay, first, in order to solve, we have to get rid of the parentheses. How do we get rid of the parentheses? Yes, distribute. Good. So that would be 3 times m and 3 times 1. Okay, then we need to get all of our variables on one side of the equation. Now, just like moving the 5, right, if we want to move this 3 over to the side of the equation, we would subtract, right? We'd do the opposite of addition. You do the same thing to move variables. So this is a positive 3m. If I wanted to join its friends over here, right, what am I going to do? They're not like terms because they're not on the same side of the equation. We have to use inverse operations to move things across that equal sign. Okay? So you're always going to use either addition or subtraction, and it should be the opposite of what's there. So we're going to subtract it. Okay, I didn't hear you. Okay, so we're going to subtract what, Cameron? The 3 or the 3m? The 3m. We're going to subtract the 3m from both sides. Okay, and then we're left with 3 equals 12m. Now, some of you even got this far, but then we still had an issue, right? Which is, which number do I divide by? Do I divide by the 3 or do I divide by the 12? 12. The 12, because we always want to undo what's being done to the variable. So we want to unmultiply. We unmultiply by dividing. So we divide by 12. And we get m equals 1/4 or 2500. Okay? Okay, I'd love to hear your questions. What questions do you have about this? Okay, on a scale from 1 to 5, okay, what's your comfort level with this type of problem? 1, I wonder what we just did. 5, I could teach it to someone else. Where are you? 3. Thank you. Okay, let's talk about A. Can you put your hands down? All right. Number 7. Lizzie's not here. 35. Yeah. Not here. 10. They're so lucky. Allie, you're up. Yes. Help us walk through A. So everybody's going to turn and face Allie. Okay, everybody turn and face Allie. We're waiting for everybody to turn and face Allie. Allie's your speaker. Okay. All right, Allie, how are we going to set this up?
So I did 9 times 14 equals equals 2a.
Okay.
And then I multiplied 9 and 14, and that's 126 equals 2a. Then I divided 126 by 2 and got 63 equals a.
Bravo.
Okay, any questions for Allie? Okay. I don't know that we are going to have time to talk about properties of proportions, and I don't want to get into this without being able to finish it. Okay? So here's what I'd like to do. I'd like to adjust the practice that I'm going to assign you for this section. Okay? So let's take a look. Okay? Hold on. I'll wait for you.
Because I start a new page.
Okay? We're not doing all of these. Okay? So what I'd like to do is I want you to do 1 and 2. And then we're also going to do 9 through 16. Okay, so on page 436 and 437, we're going to do numbers 1 through 2 and 9 through 16. 16. 9 through 16. Okay, so I have these problems, okay, because I know we don't have enough books to go around, so I have copies. I don't want you to write on them. Okay, I'm going to give 1 to each table group, okay, so that you can start on this now. Okay, I'm also going to pass around, hold on. I'm also going to pass around a sticky note, okay, and on that sticky note, I need you to use that for your exit ticket. Okay, here's what you're going to write on your exit ticket. Okay, I'm not giving you the sticky notes yet because I want your attention. Okay, so you're either telling me you have a very, very strong understanding of ratios, like you're good to go, you can teach it to somebody else. If that's true, then you're going to write a green statement for me, and your statement could include, I understand Okay, and then you're going to be very specific about what you understand. Okay, so this is you're only making a green statement, okay, if you could teach this to someone else. Okay, or you're going to give me a yellow. Okay, so you might still have a pretty good understanding if you're a yellow, but maybe you have a question or you need more practice with something. So this would be, I have a question about, okay, and you're going to write your question, or I need more practice with, okay, or you were red. Okay, hold on. Okay, sit down. I know I'm running tight on time. Okay, so what I'd like to do while I'm finishing this up, okay, is Olivia's going to hand you your exit ticket, okay? Okay, red is my learning stopped today because, and you're going to describe. Okay, and then you're going to put your sticky notes on the stop sign on the way out, either a green, a yellow, or a red. Okay, green, yellow, or red.
Did you put our name on it?
No, but if you would like to, if you want me to address your specific question, you can put your name on the back. To see if you would notice. Are you taking driver's ed? It's a really good observation, Jack.
I start on Saturday.
You do not have to put your name on it, but you can if you want me to address your specific question. Jack, can you sit, please?
I can get my pencil.
Can you sit, please? I will get your pencil.
So I have reference. I apologize, but
That's okay. You're fine. I can make another copy.
it says number 16. What's the extended ratio?
You can look in the book for that. There's a definition of extended ratios in 7.1. Okay. And we are just about out of time. So, you're going to put your sticky note on your stop sign on your way out. Please push in your chair. Jack, please push in your chair. Thank you for pushing in your chair.